86,164 seconds. That is how long the Earth takes to turn around once, and it is the most reliable number in your life. Your sleep runs on it. Every clock you own exists to divide it up. It has held for 4,500 million years without missing once, and nothing is turning it. There is no engine inside the Earth, no mechanism, no supply line. The rotational energy stored in this planet is somewhere around 100,000 times what all of human civilization burns in a year, and not one joule of it is being replenished. You learned somewhere that moving things need something to keep them moving. That is not a law of physics. That is a description of friction, and out there is none. So the real question was never what keeps the Earth spinning. It is why anything is spinning at all, and why, in 4 centuries of looking, nobody has ever found a single object at any scale that is not. Get comfortable. Hit subscribe if you're new here, because by the end of tonight you will know exactly why everything in the universe turns, and the reason has nothing to do with anything ever starting it. Now, let's slowly ease into this. Part 1. The thing that never stops. There is a number that governs your entire life, and you have almost certainly never heard it spoken aloud. 86,164.0905 seconds. That is how long the Earth takes to complete one full turn, measured properly, against the distant stars rather than against the sun. Call it a day, and you have rounded it. Call it 24 hours, and you have rounded it further. The real figure has 5 decimal places, and it is the most reliable thing in your experience. Your sleep runs on it. Your body temperature rises and falls on it. Every clock you own is a device for subdividing it. And nothing is turning it. That figure, incidentally, is not the 24 hours on your wall, and the gap between them is worth a sentence. 86,164 seconds is how long it takes the Earth to turn once relative to the stars. 86,400 seconds is how long it takes to bring the sun back to the same place in the sky, and the difference of very nearly 4 minutes exists because the planet has moved a little way along its orbit in the meantime and has to turn a little further to catch up. The day you live by is the longer, messier one. The day the planet actually keeps is the shorter one, and it is the one that matters here. I want you to sit with that for a moment, because the sentence sounds like a riddle, and it is not. It is a flat description of the situation. There is no engine inside the Earth. There is no mechanism driving the rotation, no continuing input, no source of power keeping it going. The planet has been turning for something in the region of 4.5 billion years, and in all that time, not one thing has pushed it. The rotation is not being maintained. It is simply happening, and it has never required a reason to continue. The energy involved is not small, which is part of why this ought to bother you more than it does. The rotational kinetic energy stored in the Earth is roughly 2 times 10 to the 29th joules. Written out, that is a 2 followed by 29 zeros. To give it a shape you can hold, it is somewhere in the region of 100,000 times the total energy consumption of human civilization in a year. Every power station, every engine, every furnace, every fire, for a whole year, multiplied by 100,000. That is what is sitting in the Earth's rotation right now, and none of it is being replenished. There is no supply line. There never was. Here is where the intuition breaks, and I want to name the intuition precisely, because most people carry it without ever examining it. You believe, at some level below argument, that motion needs a cause. Push a book across a table and let go, and it stops. Take your foot off the pedal, and the car slows. Stop pedaling, and the bicycle coasts to a halt. Stop stirring, and the tea settles. Every single one of those experiences teaches the same lesson, thousands of times over the course of a childhood, until it stops being a lesson and becomes an assumption about how the world is built. Things that move need something to keep them moving. That assumption is not a description of physics. It is a description of friction. Friction is everywhere on the surface of a planet with an atmosphere and a solid crust, and it is so completely everywhere that it disguises itself as a law of nature. Remove it, and the picture inverts. In a vacuum, with nothing to rub against and nothing pulling sideways, an object that is turning simply keeps turning. Not for a long time. Not until something wears out. It keeps turning, full stop, with no expiry and no decay built into the arrangement anywhere. So the Earth is not defying anything by continuing to rotate. It is doing the ordinary thing. It is the book sliding on the table that is the exception, the special case, the situation contaminated by a surface. The strange case is the one you see every day. The normal case is the one hanging over your head, silent, unpowered, and turning. Which means the question everybody instinctively asks is the wrong question. People ask what keeps the Earth spinning, and the answer is genuinely boring. Nothing has to. That is the end of that inquiry, and it takes one sentence. But underneath it, unasked, is a question that is not boring at all, and it is the question this entire video exists to answer. Why is it spinning in the first place? Not why does it continue? Why did it ever start? Where did the turning come from? Something, at some point, gave this planet a rotation, and the rotation has been running ever since, undiminished, unhelped, and unexplained, for longer than there has been life on its surface. And the moment you start pulling on that thread, you find it does not stop at the Earth. Because it is not just the Earth. Look up, and everything you can see is turning. The moon is turning. The sun is turning, and not even at a single rate. Every planet in the solar system is turning, including one that turns backwards and one that lies on its side. Every star you can pick out with your eyes is turning. The galaxy those stars sit in is turning, carrying all of them around a center they will never reach. And at scales where the word galaxy becomes a unit of measurement rather than an object, structures hundreds of millions of light years long appear to be turning as well. Nobody has ever found an exception. Not one object at any scale, examined closely enough to check, has turned out to be genuinely and permanently at rest with respect to rotation. That is not a tendency. That is not a common feature. That is a total pattern with no counterexamples in the observable universe. And total patterns in physics almost always mean that something structural is underneath them. Stand outside on a clear night and understand what you are actually looking at. Not a collection of objects that happen to be moving. A universe in which every single thing, without exception, is turning, and in which not one of those things has anything driving it. There is a reason for this. It is a real reason, a specific one, and physics can state it precisely. But it is not the reason you would guess, and it is not the reason that gets given in a classroom, and by the time we get to it, roughly 2 hours from now, it will have stopped being a fact about rotation and become a fact about the universe as a whole, one that most people find genuinely difficult to sit with the first time they hear it stated plainly. To get there, we have to go slowly. We have to look at how much rotation there actually is, and where it hides, and how astonishingly little of it was needed at the beginning. We have to understand why it cannot be destroyed, which turns out to be a statement about the shape of space rather than about any object inside it. We have to watch it move from one body to another, which is happening above your head tonight and can be measured in centimeters, and we have to find out what the total comes to. That last one is where the strangeness lives. For now, hold on to the plain version. 86,164 seconds. Once around, every time, without fail, for 4.5 billion years. And nothing is turning it. Part 2. A census of everything that turns. Let us do the count properly, because the totality of the pattern is itself the first piece of evidence, and you cannot feel the weight of it from a summary. You have to walk up the ladder, rung by rung. Start close to home. Jupiter, the largest object in the solar system after the Sun, completes a full rotation in 9 hours and 55 minutes. That is a planet 11 times the diameter of the Earth, containing more than twice the mass of everything else orbiting the Sun combined, and it turns over faster than you sleep. It is spinning hard enough that you can see the consequence with a modest telescope from a back garden. Jupiter is visibly squashed. Its equatorial diameter exceeds its polar diameter by about 6.5%, because the material at its equator is being carried around at roughly 12.5 kilometers per second, and the planet has bulged outward in response. The Earth does the same thing, more subtly. Our equatorial radius exceeds our polar radius by about 21 kilometers, a bulge of some 42.7 kilometers across the full diameter. The planet you are standing on is not a sphere, and the reason it is not a sphere is that it turns. Venus turns too, but it turns wrong. One rotation takes 243 Earth days, which is longer than its year of 225 days, so a Venusian day outlasts a Venusian year. And it turns backwards, retrograde, the only planet in the solar system whose rotation runs counter to its orbit. Uranus, meanwhile, is lying on its side, its rotation axis tipped almost into the plane of its orbit, so that each pole spends decades in continuous sunlight, followed by decades of darkness. Saturn's rotation was genuinely uncertain for decades, which tells you something about how hard these measurements are. There is no solid surface to track, and unlike every other giant planet, Saturn's magnetic field is aligned so precisely with its rotation axis that it produces no useful radio wobble to time. The figure of roughly 10 hours and 33 minutes came eventually from ring seismology, reading the rotation of the planet in the vibrations it induces in its own rings. Go inward to the Sun, and the pattern holds while the object stops behaving like a solid. The Sun's equator completes a rotation in about 25 days. Material near its poles takes about 34.4 days. It is not turning at one rate, it is turning at a continuum of rates, faster at the middle and slower at the ends, which is possible because it is a ball of plasma with no rigid structure holding it together. Richard Carrington established this systematically in the 1850s by patiently tracking sunspots across the disk, year after year, and watching the ones near the equator outrun the ones at higher latitudes. Now the moons, and here is where a common misconception needs correcting. The moon is tidally locked to the Earth, showing us the same face permanently. Most people file this as the moon not rotating. The opposite is true. The moon rotates once for every orbit it completes, one turn every 27.32 days, and the two periods match to a precision that no clock in your house could achieve. A tidally locked body is not a body that has stopped turning. It is a body whose turning has been tuned, over billions of years, into exact agreement with its orbit. It is the most precisely regulated rotation in the solar system. Keep climbing, young stars, the T-Tauri stars, still contracting, not yet burning hydrogen properly, rotate in 1 to 10 days, far faster than the mature sun. White dwarfs, the exposed cores of dead stars compressed to roughly the size of the Earth, rotate in hours. The Crab pulsar, a neutron star born in a supernova witnessed from Earth in the year 1054, turns about 30 times every second, and then the ladder gets steep. The fastest known spinning object in the universe is a neutron star called PSRJ 1748-2446 AD, found in the globular cluster Terzan 5, roughly 18,000 light-years away. It was discovered by Jason Hessels and his collaborators using the Green Bank telescope and published in Science in 2006. It rotates 716 times per second. Not 716 times per minute, per second. Its surface is moving at approximately 24% of the speed of light, and it broke a record held for 24 years by a pulsar spinning at 642 Hz. That object is harder to find than it should be, and the reason is worth a moment. It sits in a binary system, and its companion is bleeding material into space that blocks the radio pulses for roughly 40% of every orbit. For 2/5 of its time, it is simply invisible. The team that found it made a point of saying so in the paper, and drew the obvious conclusion: if a pulsar this fast is this easy to miss, then faster ones are almost certainly out there, hidden behind the same kind of veil. The record we have is a record of what we have managed to detect, not a record of what exists. Terzan 5, for what it is worth, is a factory for these things. An unusually crowded globular cluster near the galactic bulge, where close stellar encounters keep manufacturing exactly the kind of binary that produces a millisecond pulsar, and dozens of them have been found in that one cluster alone. Black holes rotate as well, and physicists measure it with a dimensionless number that runs from 0 to a theoretical maximum of 1. The black hole in the system, GRS 1915 plus 105, has been measured above 0.98, sitting, in other words, almost exactly at the geometric limit of how fast a black hole is permitted to turn. Above that, galaxies. The Sun completes one circuit of the center of the Milky Way in roughly 225 to 250 million years, traveling at something like 230 kilometers per second. The last time it was where it is now, the first dinosaurs were appearing. And above that, this is recent and remarkable, the filaments themselves. The cosmic web is built of thread-like structures of galaxies, hundreds of millions of light-years long, and only a few million light-years thick. In 2021, a team led by Peng Wang published evidence in Nature Astronomy that these filaments are rotating about their own long axes. They are the largest objects known to carry any angular momentum at all. So here is the census. Atoms, moons, planets, stars, stellar corpses, black holes, galaxies, and the largest structures in existence. Every rung occupied, no gaps, and in more than 4 centuries of pointing instruments at the sky, nobody has ever found a single object, at any scale, that turned out to be genuinely and permanently at rest with respect to rotation. Now stand still for a moment and count what is carrying you. You are not moving. You are sitting or lying down, perfectly stationary, and you can feel that you are stationary. The floor is not sliding. Nothing is pressing you sideways. There is no wind. And underneath that stillness, there are 5 separate rotations carrying you at once. The surface of the Earth is sweeping you eastward at a few hundred meters per second, faster than most passenger aircraft. The Earth is carrying you around the Sun at 29.78 kilometers per second, about 67,000 miles an hour. The Sun is carrying the whole solar system around the galactic center at roughly 230 kilometers per second. The galaxy is moving within the local group, and the local group is moving at something like 620 kilometers per second relative to the oldest light in the universe. 5 motions. Not one of them detectable by any sensation available to a human body. You cannot feel a single one, and you never will, because none of them is accelerating you noticeably. They are simply the conditions you were born into, the way the floor is a condition rather than an event. Everything turns. Nothing has to be pushed, and so far, nobody has told you why any of it is turning at all. Part 3. The rule that is not about objects. The textbook answer to why rotation persists is a quantity called angular momentum, and the textbook demonstration is a figure skater. She spins with her arms out, pulls them in, and speeds up dramatically. The quantity that stayed the same through that maneuver is angular momentum, roughly how much mass is turning, how fast it is turning, and crucially, how far that mass sits from the axis. Pull the mass inward, and since the product has to stay fixed, the rate has to climb. The arithmetic is correct. Every physics class in the world teaches it this way, and it works. I want to spend a moment dismantling it, because it is the most misleading correct explanation in physics. The skater analogy quietly teaches you 3 wrong things. The first is that spin comes from a decision. She chooses to pull her arms in. She chooses to speed up. In every case we are going to look at tonight, nothing decides anything. A collapsing cloud of gas has no arms and no intentions. The second is that she is doing work. She is pulling her arms inward against the outward push she feels takes real muscular effort, and the energy for the extra rotation comes from her body. But a star collapsing under its own weight is not doing work against anything. Gravity is doing the pulling for free, and the acceleration comes anyway. The third and worst is that the analogy makes rotation feel like a property of the skater, something she has and manages and controls. Rotation is not a property of the object. It is a quantity the object is holding. That distinction is going to carry the entire rest of this video, so let me put it as plainly as I can. Angular momentum behaves less like a characteristic and more like a balance in an account. It can be transferred from one body to another. It can be split, pooled, handed on, but it cannot be created out of nothing, and it cannot be destroyed. Think of it as a ledger. Every entry has to come from somewhere and go somewhere, and the books close exactly, every time, with no rounding and no allowance for circumstances. Now, why? Why should the universe run a ledger like this at all? The honest answer is not the one that gets given. The usual answer is that angular momentum is conserved because there is no torque acting, which is true and also circular. It amounts to saying that nothing changed it because nothing changed it. The real answer was worked out in 1918 by a German mathematician named Emmy Noether, and it is one of the deepest results anyone has ever produced about how physical law is put together. Noether was working at Göttingen at the time, unpaid, denied a formal position for years on the grounds that she was a woman. David Hilbert, arguing on her behalf before the faculty senate, reportedly asked his colleagues whether they imagined the university was a bathhouse. The paper she produced that year, Invariante Varianzusprobleme, published in the Proceedings of the Göttingen Scientific Society, established something that now organizes essentially all of theoretical physics. Her theorem says this: for every continuous symmetry of a physical system, there is a corresponding conserved quantity. A symmetry, here, means something you can change about the setup without changing the physics. Move your entire experiment 10 meters to the left. Everything behaves identically. The laws of physics do not care where you are. That symmetry, the sameness of physics from place to place, is exactly what gives you conservation of momentum. Run the same experiment tomorrow instead of today. Everything behaves identically. The laws of physics do not care when you are. That symmetry gives you conservation of energy. And now the one that matters tonight. Turn your entire experiment to face a different direction. Rotate the whole apparatus 90 degrees, or 180, or any angle you like. Everything behaves identically. Space has no preferred direction. There is no cosmic north, no orientation the universe considers special, no way to build an experiment that behaves differently depending on which way you point it. That symmetry, and nothing else, is what gives you conservation of angular momentum. Sit with the size of that. Rotation persists. The Earth turns for 4.5 billion years without an engine, not because of any property of the Earth, not because of its mass, or its composition, or its structure, or the vacuum it sits in. It persists because space itself is indifferent to direction. If space had a preferred direction, if there was some orientation the universe subtly favored, some axis built into the geometry, then rotation would not be conserved. Spinning objects would slowly leak their rotation away into the structure of space, with no friction required, and the universe would gradually and permanently stop turning. It does not. It has not. Every rotating thing you counted in the last 20 minutes is a piece of evidence that space is exactly as orientation blind as it appears to be. That is what is actually holding the day at 86,000 seconds, not the Earth, the shape of space. If that sounds abstract, here is a case where the symmetry genuinely fails, and it will sharpen the point. Take a crystal, a lattice of atoms arranged in a repeating structure. Inside a crystal, direction matters enormously. There are axes along which the atoms are packed tightly, and axes along which they are spread. A wave traveling one way through the crystal behaves differently from a wave traveling another way. The crystal has broken the rotational symmetry of space for anything living inside it, and the consequence is immediate and measurable. Angular momentum is not conserved for a particle moving inside that lattice. It can be exchanged with the crystal structure itself in discrete amounts, and physicists have to keep track of that exchange explicitly. The conservation law does not hold there because the symmetry does not hold there. Empty space is not a crystal. That is the whole content of the law. As far as anyone has ever been able to measure, and people have looked hard, with atomic clocks and with astrophysical signals crossing billions of light years, space has no grain, no preferred axis, no built-in orientation, and so the ledger holds. You can also put your hands on this, if you want to. A gyroscope is nothing but a device for storing an orientation, and it works for exactly one reason. The angular momentum in the spinning wheel cannot go anywhere, so the axis stays pointing where it was pointed. Every inertial navigation system in every aircraft and submarine in the world is running on that. When a plane crosses an ocean with no view of the sky and no signal from a satellite, and still knows which way it is facing, what it is relying on, at the bottom, is that space has no preferred direction. Noether's theorem is not an abstraction in a textbook. It is load-bearing infrastructure. And I should be precise about one limitation, because it matters later. Angular momentum is conserved for a closed system, one with nothing reaching in from outside to twist it. When something does reach in, the quantity changes, and the conservation law does not fail. It simply widens to include whatever did the twisting. The ledger does not get smaller when a transaction happens. It just gains a second column. There is one thing I should name and set aside before we go on, because if I do not, it will nag. Electrons, protons, and every other fundamental particle carry angular momentum too, an intrinsic amount, measured in units of 1/2 of the reduced Planck constant, and it is called spin. It has the same units as ordinary rotation. It obeys the same conservation law. It enters the same ledger. But it is not a little ball turning. Electrons are not spheres and they are not rotating. The quantity is intrinsic to what they are, in the way that charge is intrinsic, and it has no classical picture behind it that survives inspection. It is a genuine subject, and it is not tonight's. When I say rotation from here on, I mean the ordinary kind. Objects turning about axes, at rates you could time with a stopwatch if you had a good enough one. So, rotation cannot be destroyed. Nothing in the universe has the power to remove angular momentum from existence, because to do that, you would have to break a symmetry of space, and nothing has ever been observed doing that. Everything that follows from here is a consequence of that one restriction. When a star collapses, the rotation does not go anywhere, so something else has to give. When the Earth slows down, the rotation does not vanish, so it has to be somewhere else, and we can go and look for it. When a neutron star hits the limit of what matter can survive, the rotation still cannot be destroyed, so it has to find another counterparty, and it does, in a place that should not be available to it. The ledger balances every time. It has never failed. Which raises a question that nobody has asked yet tonight, and which turns out to be the only question that matters. If angular momentum can only ever be moved from one place to another, then the amount in existence was fixed at the very beginning and has not changed since. So what is the total? Hold that. We are not ready for it yet. First, we need to understand how a quantity that cannot be created managed to produce a neutron star turning 716 times a second. Part 4. How almost nothing becomes almost everything. There is a piece of arithmetic buried in the conservation law that most explanations skate past, and it is the single most consequential fact in this entire subject. Angular momentum depends on the distance of the mass from the axis, and it depends on that distance squared. Take that seriously for a moment. If the angular momentum is fixed and the object shrinks, the rotation rate has to rise, not in proportion to the shrinking, but in proportion to the square of it. Halve the radius, and you quadruple the rate. Reduce the radius by a factor of 10, and the rate goes up 100-fold. The relationship is not gentle. It is an amplifier, with a gain that climbs violently as things get smaller, and the universe spends most of its time making things smaller. Let me walk you through what that does in practice, with real numbers, because the size of them is the argument. Begin with a molecular cloud core. These are the birthplaces of stars, cold, dark regions of gas and dust drifting in the space between stars, typically about a light year across. A light year is roughly 10,000 million meters. Write it as a 1, followed by 16 zeros. Now give it a rotation so slow that it is effectively meaningless. Say 1 full turn every 10 million years. I want to be clear about how slow that is. If you were somehow able to stand inside that cloud with the finest instruments ever built, you would not be able to detect the rotation at all. It is not slow like a clock hand. It is slow like continental drift is fast by comparison. 10 million years for one revolution is a rate that does not register as motion by any standard a human being possesses. That cloud collapses. Gravity is patient, and it always wins eventually. And over a few 100,000 years, the cloud falls inward on itself. You are inside it as it goes. At first, almost nothing happens. The collapse is slow, and the rotation is imperceptible. Then, as the radius drops, the square law begins to bite. At 1/10 of the original size, the rotation is 100 times faster, which is still nothing you could notice. At 100th, 10,000 times faster. At 1,000th, 1,000,000 times. The rate is not creeping up. It is running away, faster the further the collapse goes, and there is no point at which anything intervenes to slow it. By the time the collapsing core has reached the size of a star, roughly 700 million meters in radius, so a shrinkage of about 10 million from where we started, the rotation rate has been multiplied by 10 million squared. That is a factor of 100 million. The cloud that took 10 million years to turn once is now turning in a matter of hours. A factor of 100 million is difficult to hold in the head, so let me anchor it. If you took the thickness of a sheet of paper and multiplied it by that number, you would get a distance of around 10,000 million kilometers, comfortably past the orbit of Neptune. That is the gap between the rotation the cloud started with and the rotation the star ended with, and gravity crossed it without any help. Nothing was added. That is the part to hold on to. At no point in that entire collapse did anything push, or twist, or supply rotation. Not a single joule of rotational energy came in from outside the system. The violence at the end was already present, at the beginning, folded up in a motion too slow to see. And the universe does not stop there. When a massive star exhausts its fuel, its core collapses again, and this time from something roughly the size of the Sun down to a ball of neutrons about 12 kilometers across. You could drive across it in 10 minutes. That is a further shrinkage by a factor of about 60,000, which the square law converts into an increase in rotation rate of about 3,500 million. Run that on a stellar core that was turning, let us say, once a month. Once a month is a leisurely rotation, slower than the Sun's. Multiply it by 3,500 million, and you get an object turning roughly 100 times every second. That is where the pulsars come from. Not from anything spinning them up. From a slow rotation, inherited from a cloud that inherited it from somewhere else, run through two successive gravitational collapses, and amplified by pure geometry. Now put yourself above the equator of the fastest one anybody has found. You are looking down at an object about 20 kilometers across, the size of a small city, containing more mass than the Sun. It is turning 716 times every second. Every 1.4 milliseconds, the entire star comes back around. The surface directly beneath you is moving at roughly a quarter of the speed of light, 70,000 kilometers every second, and it is doing it in complete silence, because there is no medium out here to carry a sound. If there were, the tone would sit near the top of a piano keyboard, held indefinitely, never wavering. This object has been ringing that note for hundreds of millions of years, and nothing is turning it. Nothing ever did. What you are watching is a very slow motion from a very long time ago in a very large cloud put through a compression. Not every star ends as a neutron star, and the intermediate case is instructive. A star like the Sun finishes as a white dwarf, a core compressed not to 12 kilometers, but to roughly the size of the Earth, a shrinkage of about 100 rather than 60,000. The square law duly delivers about 10,000 rather than 3,500 million, and white dwarfs are found rotating in hours rather than in milliseconds. The same rule, the same inheritance, a smaller compression, a proportionally smaller result. Nothing about the mechanism changes, only the number you feed into it. There is a consequence of all this that reaches well beyond how fast things turn, and it is worth naming because it touches your life directly. Rotation, in a body made of moving conductive fluid, generates magnetism. A rotating, convecting interior stretches and twists magnetic field lines and sustains a field that would otherwise decay away. This is the dynamo, and it is why the Earth has a magnetic field at all, which is why the planet has a magnetosphere, which is a substantial part of why the atmosphere is still here. The strength of that effect depends on how fast the body rotates relative to how fast its interior churns, which means the young Sun, rotating in days rather than weeks, was not merely a faster version of the present one. It was a far more magnetically violent object, throwing out flares and winds on a scale that would be unrecognizable today. The rotation an object inherits does not just set how quickly it turns, it sets how dangerous it is. There is a second consequence of this square law that deserves naming, because it explains a shape you have seen in every picture of a forming star or a black hole, and most people have never been told why it is there. When material falls toward a center, it cannot fall straight in. Its angular momentum forbids it. As it approaches, the same amplification kicks in, the rotation rate climbs, and the material ends up sweeping around the center far too fast to reach it, so it cannot land. Instead, it settles into the only configuration that resolves the conflict. It flattens into a disk, orbiting, unable to get closer. The material in that disk only ever spirals inward, as fast as it can get rid of its angular momentum, which it does slowly, by friction between neighboring rings, the inner material handing rotation outward to the outer material, one layer at a time. Every accretion disk in the universe, every protoplanetary disk that ever built a solar system, every glowing ring around a black hole, is the visible shape of matter trying and failing to fall in against a quantity it cannot get rid of. The disks are not decoration, they are the ledger, made visible at the scale of a galaxy. Which brings us back to the question we have been carefully avoiding. All of this amplification is real, and none of it creates anything. The neutron star did not manufacture its rotation. The cloud did not manufacture its rotation. Something, somewhere, had to hand it over. So where did the very first twist come from? Part 5. The twist that came from the neighbours. If angular momentum cannot be created, then every rotating object in the universe is holding something it was given, which means the whole thing is an inheritance, and inheritances can be traced. You follow the transfers backwards, one hand to the previous hand, and you keep going until you run out of hands. Where you run out is a piece of physics called tidal torque theory, and it has a slightly sad history for a result this important. Fred Hoyle proposed the essential idea in 1949. Hoyle was one of the most inventive astrophysicists of the 20th century, and also one of the most contrarian. And this particular idea of his was almost completely ignored for 2 decades. It sat in the literature, unused, until Jim Peebles revived it in 1969. Alexander Doroshkevich gave it its proper mathematical form in 1970, and Simon White completed the modern treatment in 1984. 35 years from proposal to finished theory, most of it spent being overlooked. Here is what it says, and I want to build it carefully, because it is not complicated, but it is easy to state in a way that sounds like magic. Go back to the early universe, well before there were stars or galaxies or anything you would recognize. The matter is spread out almost perfectly evenly. Almost. The variations in density from place to place are about 1 part in 100,000. You can measure them directly, imprinted in the oldest light in the universe, and they are astonishingly small. If the Earth's surface were that smooth, the tallest mountain on it would be about 60 meters high. Now, one of those very slightly denser regions is going to become a galaxy. Not yet. Right now it is just a patch of gas, fractionally denser than its surroundings, being pulled together by its own gravity while the universe expands around it. That patch is not a sphere. Nothing at that scale is. It is lumpy, and slightly elongated, and irregular, because it condensed out of a random field of fluctuations rather than being manufactured. It is a shapeless blob, with a long direction and a short direction. And it has neighbours, other patches, also slightly overdense, sitting nearby, pulling on it gravitationally. Now here is the mechanism, and it turns entirely on that irregularity. Gravity weakens with distance, so a neighbour pulls harder on the near side of our patch than on the far side. If the patch were a perfect sphere, that difference would stretch it and nothing more. But it is not a sphere, it is an elongated blob, and it is not aligned with the direction of the pull. Why would it be? The near end and the far end are offset from the line to the neighbour, and the unequal pull on 2 offset ends is not a stretch. It is a twist. That is the whole idea. No neighbour has to do anything unusual. Nothing has to swirl, or vortex, or collide. All that is required is that a lumpy object sits in the gravitational field of other lumpy objects, misaligned, which is the default condition of everything in a universe built out of random fluctuations. The asymmetry alone is sufficient. Gravity supplies the rest. The patch begins to turn. Slowly, the torques are tiny, and they are being applied across distances measured in millions of light years. But they accumulate, and in the early phase they accumulate steadily, with the angular momentum growing in direct proportion to the age of the universe. That linear growth is not a story. It is a prediction of the theory, and it has been checked against simulations, and it holds. Then the growth stops, and the way it stops is elegant. As the patch pulls itself together, there comes a moment called turnaround, the point at which its own gravity finally overcomes the expansion of the universe, and it stops expanding and starts to collapse. At turnaround, it decouples from the general flow. It becomes a self-contained object rather than a slightly dense region of a spreading background. And the moment it does that, the tidal talking from its neighbours effectively switches off. The geometry that was applying the twist no longer applies in the same way. Whatever angular momentum it had at that moment is what it keeps, forever. That is the inheritance, and the collapse we walked through in the last part is what happens to it afterwards. Now for the number, and this is the number I would most like you to remember from tonight. Physicists measure how much rotation a structure has using a dimensionless quantity called the spin parameter, essentially how fast it is turning compared with how fast it would need to turn for rotation alone to hold it up against its own gravity. A spin parameter of 1 would mean the object is entirely supported by its rotation, on the edge of flying apart. A spin parameter of 0 would mean it is not turning at all. The measured value, for essentially every structure ever examined, is about 0.035, 3.5%. That is how much rotation the early universe handed out. Every galaxy is turning at something like 3 or 4% of the rate that would be needed to matter dynamically. In terms of what actually holds a galaxy together and gives it its shape, rotation is close to an afterthought. And the distribution of that number across structures is remarkable in its own right. It follows the same statistical shape across an enormous range of masses, from objects that will become dwarf galaxies to objects that will become the largest clusters, with the same median and roughly the same spread, more or less independent of mass, of epoch, and of the details of the cosmology. It is one of the more universal results in structure formation, and it is universal because the mechanism producing it does not care how big the patch is. Lumpiness and misalignment are scale-free. The same twist gets applied at every size. Small as that number is, it decides more than it sounds like it should. The angular momentum a galaxy inherits is what sets its size. Two galaxies with identical mass, but different spin parameters, do not end up looking alike. The one with more rotation settles into a larger, thinner, more diffuse disk, its material held further out, its light spread over a wider area. The one with less rotation ends up compact and bright. When you look at photographs of spiral galaxies and notice that some are grand and open, while others are tight and concentrated, a substantial part of what you are seeing is a difference in how hard the neighbours happened to be pulling 10,000 million years ago. The theory is not finished, and it is worth saying where it strains. In its simplest form, tidal talking alone underpredicts how much angular momentum some disk galaxies actually have. Simulations suggest the shortfall is made up later, by gas continuing to stream in along the filaments of the cosmic web long after turnaround, arriving with rotation of its own and delivering it to the disk. So the inheritance is not a single lump sum paid at one moment. Some of it arrives late, in installments, along channels that were laid down by the same gravitational field that applied the original twist. So this is the picture, and I want to state it in the bluntest terms available. Everything that turns in the universe, every planet, every star, every neutron star screaming round 700 times a second, every spiral arm of every galaxy in every photograph you have ever seen, is running on a twist that was applied, before any of it existed, by the uneven gravitational pull of neighbouring lumps of gas that no longer exist in any recognizable form. The material that did the twisting has long since been rearranged into other galaxies, other stars, other planets. The push is over. The turning is not. Nothing generated its own rotation, not one thing. Every spinning object you can point at received it, and received it from something that has since dissolved. And notice, because this is the thread we cannot let go of, that even this is not creation. The twist did not come from nowhere. It came out of the gravitational field of the surrounding matter, which means it was transferred, not generated. The neighbours pulled on our patch, and our patch pulled back on the neighbours, exactly as hard, in exactly the opposite sense. The ledger was balanced at that moment too, which should be starting to feel uncomfortable, if you are following where this goes. Because if every twist was matched by an opposite twist somewhere nearby, then the sum of all of them may not be what you would expect. We are not there yet. First, there is a problem much closer to home, a body we can see from here, that has almost all the mass in this solar system and almost none of the rotation, and that should not be possible. Part 6. The star that should be spinning far faster. The Sun contains 99.86% of the mass of the solar system. That figure is so lopsided that it changes how you should picture this place. Everything else, Jupiter, Saturn, Neptune, Uranus, the Earth, every moon, every asteroid, every comet, the whole inventory, adds up to about 1/7 of 1%. The solar system is the Sun, plus debris. Now ask where the rotation is. The Sun holds a few percent of the solar system's angular momentum at most. The figure quoted in the literature runs between roughly 0.3 and 2%, depending on how you do the accounting, and the exact value matters less than the shape of it. Jupiter and Saturn between them hold more than 90%. Read those two facts against each other slowly. The object with 99.86% of the mass has, at best, a couple of percent of the rotation. Two planets that together amount to about 1,000th of the Sun's mass are holding almost all of it. This should not happen. Work through the collapse we described earlier, and the expectation is unambiguous. A cloud contracts. Most of the mass ends up in the middle, and the angular momentum should follow the mass. The center should be spinning ferociously. And it should have been. If the Sun had retained the angular momentum of the material that formed it, it would not be turning once every 25 days. It would be turning in hours, flattened by its own rotation, sitting near the edge of stability. It is not. It is a slow, sedate, almost boring rotator. This is an old problem, and it was once a serious threat. When Pierre-Simon Laplace set out the idea that the solar system condensed from a rotating cloud, at the end of the 1700s, this imbalance was one of the strongest objections raised against him, and it stayed a live objection for well over a century. If the whole system came from one spinning cloud, critics asked, why is the spin in the wrong place? For a long time there was no good answer, and the awkwardness of it drove people toward alternative theories of the solar system's origin that we now know to be wrong. The correct explanation required magnetism and plasma physics and an understanding of young stars that nobody had until the middle of the 20th century. It is also not a peculiarity of our Sun. It is a general condition of star formation, and in its general form it is worse. Take a typical molecular cloud core with the rotation such cores are actually observed to have, collapse it, and conserve its angular momentum, and it cannot form a star at all. It arrives with something like 1,000,000 times too much rotation and simply shreds itself into a ring before it can ever reach stellar density. Every star that exists is a star that solved this problem. Some of the excess goes into splitting the collapsing core into a binary pair, which is part of why so many stars come in twos. Some goes into the disk, some is thrown back out in the jets and outflows that young stars fire from their poles. Star formation is, from a certain angle, less a story about gravity pulling matter together than a story about matter frantically trying to get rid of its rotation fast enough to be allowed to become a star. So what happened to the rotation? Here is the thing. It did not go anywhere, because it cannot go anywhere. That is the point of the ledger, and this is the case where you can watch the ledger being enforced against a body that has every apparent right to win. The rotation was moved, outward, and the mechanism is one of the more beautiful pieces of astrophysics we have. A young star is not a quiet object. It is hot, violently magnetic, and surrounded by the remains of the disk it formed from, a great flat structure of gas and dust, ionized in places, orbiting. And a magnetic field anchored in a rotating star does not stay put. It is dragged around with the star, and where it threads through the surrounding disk, it becomes a set of levers. Picture it as an enormous array of elastic lines, one end fixed in the spinning star, the other end embedded in slower-moving material further out. The star drags the lines forward. The lines pull the disk material forward, speeding it up, and by exactly the same amount, the disk material pulls back on the lines, and the lines pull back on the star. The star is being braked by its own magnetic field, and the rotation it loses is being handed, line by line, to the material further out. There is a second and even more effective version of the same trick. Ionized gas leaving the star follows those field lines outward, and while it is attached to them, it is forced to keep pace with the star's rotation, like a ball on a string being swung. But it is being swung at a steadily increasing radius. By the time it detaches, at 10, 100, 1,000 times the star's own radius, it is carrying away enormously more angular momentum per unit mass than it had when it left the surface. A small amount of escaping material can therefore remove a disproportionate share of the star's rotation. This is magnetic braking, and over the lifetime of a star, it is devastatingly efficient. We can watch it happen. The T-Tauri stars, young objects, still contracting, not yet burning hydrogen in a stable way, rotate in 1 to 10 days. Older stars of similar mass rotate far more slowly, and the relationship between a star's age and its rotation rate is regular enough that it can be used, in reverse, to estimate the age of a star from how fast it turns. The models that describe magnetic braking reproduce the observed slowdown quantitatively, over timescales from millions to thousands of millions of years. There is also a related process called disk locking, in which the magnetic coupling between a young star and the inner edge of its disk holds the star's rotation rate nearly constant even while it is still gaining mass. A star that ought to be spinning up as it accretes, and is not, because the disk is taking the rotation as fast as the mass arrives. So the Sun's missing rotation is not missing. It is in the outer solar system. It is in the orbital motion of Jupiter and Saturn, and it went out along magnetic field lines and in the wind of a young and much angrier star 4,500 million years ago. I want to stop here because there is something in this that is easy to walk past and worth feeling properly. We are accustomed to a universe in which size wins. The big object dominates, sets the terms, holds the resources. The small ones orbit and comply. And in almost every respect, that is exactly what the solar system looks like. The Sun holds the mass. The Sun holds the energy. The Sun holds everything else in place with its gravity, and the planets have no say in the matter at all. And on this one quantity, the arithmetic simply overrules it. The Sun does not get to keep the rotation because it is large. It does not get an allowance for being important. Jupiter, at 1,000th of its mass, holds most of the angular momentum of this solar system, and there is no appeal, because the ledger does not weigh who is holding what. It only checks that the total is unchanged. Nothing was destroyed to make that happen. Not one unit of angular momentum was removed from existence in the entire 4,500 million year history of this system. It was moved from the center to the edge by magnetic fields, and it is sitting out there now in the orbit of a planet you can see with your eyes on a clear evening. Moved, never destroyed. That has now happened twice. Once in the early universe, when the neighbours twisted our patch and were twisted back, and once here, when a star handed its rotation to its own planets. And if it is only ever moved, then the amount in existence has never changed. Not once, not by anything, anywhere, in 14,000 million years. Which means there is a number, a single number, fixed at the beginning, for the whole universe, and nobody has told you what it is. Part 7. Let us put the pieces together. We are about halfway through, and this is a good place to stop climbing for a moment and lay out what we have, because 5 separate things have been established, and they fit together into something larger than any of them. The first is that rotation does not need maintaining. The Earth has turned for 4,500 million years, with nothing driving it. And the intuition that says motion requires a cause is not a law of physics. It is a description of friction, and there is no friction out there. In a vacuum, turning is simply what a turning thing does, indefinitely, with no expiry built in anywhere. The second is why angular momentum is conserved, because space has no preferred direction. That is Noether's result from 1918, and it is a much stranger statement than it looks. The persistence of the day is not a fact about the Earth. It is a fact about the geometry the Earth sits in. If space had a grain, a favoured axis, some orientation the universe quietly preferred, then rotation would bleed away on its own, and eventually everything would stop. It does not, and so nothing does. The third is that a very small amount of rotation goes a very long way. Because angular momentum depends on distance from the axis squared, collapse acts as an amplifier with an enormous gain. A cloud a light year across, turning once every 10 million years, a motion no instrument could detect from inside it, becomes a star turning in hours. Collapse that star's core again, and you get an object turning 100 times a second. Nothing is added at any stage. The violence at the end was present at the beginning, folded up. The fourth is where the original twist came from, and the answer is that it was never generated by anything that now holds it. Lumpy patches of the early universe were twisted by the uneven gravitational pull of their lumpy neighbours. No swirling required, just misalignment and the fact that gravity weakens with distance. The angular momentum accumulated until each patch stopped expanding and began to collapse, and then it was locked in. The amount handed out was tiny, a spin parameter of about 3.5%, meaning every structure in the universe is turning at a few percent of the rate at which rotation would actually matter to holding it up. And the fifth is the one everything else has been circling. Angular momentum can be moved, but it cannot be destroyed. The neighbours twisted our patch, and our patch twisted them back, exactly as hard. The Sun handed almost all of its rotation to Jupiter and Saturn along magnetic field lines and never got it back. In both cases, nothing vanished. The books balanced. They always balance. And there is a sixth thing, which is really the fifth, made visible. Every disk in the universe is a picture of this rule being obeyed. The rings around a forming star, the glowing band of material spiraling into a black hole, the flat plane the planets of this solar system all lie in, the rings of Saturn sitting almost exactly above its equator. None of those shapes are decorative. They are what matter is forced into when it wants to fall inward and cannot get rid of its rotation fast enough to do it. Flatness, everywhere you look in the sky, is the signature of a quantity that will not go away. If you have drifted a little, that is the whole of it in one line. Rotation is a thing that gets handed around, never made, never lost, and every flat glowing shape out there is a picture of that fact. So here is the picture as it now stands. Every rotating object in the universe is holding a quantity it did not create, cannot destroy, and can only pass on. The whole thing is one enormous system of transfers, running for 14,000 million years, in which the same conserved stuff has been handed from clouds to stars to planets to moons, amplified by geometry, moved around by magnetism and by tides, and never once added to or subtracted from. Which means something that has been sitting quietly under this whole video and has not been said out loud yet. If angular momentum can only ever be moved, then the total amount of it in existence was fixed at the very beginning and has not changed by so much as a fraction since. Every galaxy that formed, every star that lived and died, every planet, every collapse, every collision, every magnetic wind, none of it altered the sum. The books have been rearranged endlessly, and the bottom line has never moved. So there is a number. One number, for the whole universe, set at the start, unchanged ever since. And it is a number we can go and check, because a rotating universe leaves fingerprints that a non-rotating one does not. That question is where all of this has been going, and we will get there. But not yet, because the road to it runs through four things that make rotation stranger than it has been so far. The first is that one of these transfers is not ancient history. It is happening tonight, above your head, and it can be measured in centimeters. The second is that rotation is detectable in a way that ordinary motion is not, which has been an unresolved scandal in physics for 300 years. The third is what happens when a thing spins as fast as it is physically permitted to spin, and what breaks first. And the fourth is that spin, across the universe, does not point in random directions. Let us take them in order, beginning with the one you can see from your window. Part 8. The transaction you are living inside. Everything so far has been history. The twisting of the early patches happened thousands of millions of years ago. The sun handed its rotation to Jupiter before there was anything on this planet to notice. All of it is over, and only the results remain. Except for one transfer, which is not over. It is happening right now. It involves the planet you are on, and it can be measured to the millimeter. The moon raises tides in the oceans. 2 bulges of water, one on the near side, one on the far side. Everyone knows that part. What most people are never told is what happens next, and it is where the physics gets interesting. The Earth rotates once every 86,000 seconds. The moon takes 27 days to go around. So the planet turns underneath the tidal bulges roughly 27 times for every one lap the moon completes, and it drags them with it. The water cannot respond instantly. There is friction against the seabed, and the continents are in the way, and the whole system lags. The result is that the tidal bulge does not sit directly under the moon. It is dragged ahead of it, carried forward by the Earth's faster rotation, sitting a little in front of where the moon actually is. And that bulge has mass. Mass that is now slightly ahead of the moon, pulling on it. So the Earth's own tidal bulge is towing the moon forward along its orbit, adding energy to it, adding angular momentum to it. And by the same reasoning that has governed everything tonight, the moon is pulling back on the bulge exactly as hard, which means it is applying a braking torque to the Earth's rotation. The Earth is slowing down. The moon is moving away, and these are not two facts. They are one transaction, seen from the two ends. We know the numbers because somebody left equipment on the moon to measure it. A laser pulse leaves an observatory telescope and climbs out of the atmosphere. It is aimed at a patch of the Sea of Tranquility, where a panel of 100 fused silica corner cubes has been sitting, untouched and unpowered, since July 1969. There are similar arrays at 2 other Apollo sites, and on the Soviet Lunokhod rovers. A corner cube has the property that whatever direction light comes in from, it goes back out the same way, so the panel does not need to be aimed at anything. The beam spreads on the way. By the time it arrives, it is a couple of kilometers wide, and only a tiny fraction of it strikes the panel. It reflects, and spreads again on the way home. Perhaps 10 to the 20th photons leave the telescope, A handful come back, sometimes a single one. 2.5 seconds after it left, the pulse returns, and the timing is recorded. Repeat that, night after night, for decades, and the number that emerges is this. The moon is 3.8 centimeters further away than it was a year ago, about the rate a fingernail grows, measured across 385,000 kilometers, to a precision of a few millimeters. The retroreflectors are the only Apollo experiment still returning data more than half a century later, and what they have been quietly recording all this time is the ledger being settled. The other end of the transaction is the day getting longer, and here an honest complication appears that I think is more interesting than the clean version. If you reconstruct the length of the day from ancient records, Babylonian and Chinese eclipse observations, records of exactly when and where a solar eclipse was seen thousands of years ago, compared against where the mechanics say it should have been visible, you get a lengthening of about 1.78 milliseconds per century. If you reconstruct it instead from the modern record, from lunar occultations and precise Earth orientation data covering roughly 1680 to 2020, you get about 1.09 milliseconds per century. Those do not agree, and the gap is not an error. The tidal calculation is clean, the Earth is not. The planet is being pushed and pulled by several things at once, and the tidal break is only the largest of them. The crust is still rebounding upward from the weight of ice sheets that melted thousands of years ago, which changes the distribution of mass and therefore the rotation rate. The liquid outer core is exchanging angular momentum with the mantle above it in ways that are still argued about. And the atmosphere has its own tide, driven not by the moon but by solar heating, which pushes the rotation in the opposite direction, speeding the Earth up rather than slowing it. The moon is braking us. The sun's heating of the air is spinning us up. The ice sheets are still leaving. The core is arguing with the mantle, and the number you actually measure is the sum of all of it. There is also a question of where the energy goes, and the answer is disarmingly ordinary. Angular momentum is conserved, but energy is not conserved within the Earth-Moon system. Some of it has to be dissipated for the transfer to happen at all, and it is dissipated as heat by water dragging over the sea floor. The total is something like 3.5 million watts, which is a few times the entire electrical generating capacity of human civilization, and the great majority of it is deposited not in the open ocean, but in shallow shelf seas and narrow straits, where the tide has to squeeze past continents. The moon is receding because of turbulence in places like the Irish Sea and the Bay of Fundy. That is a genuinely strange sentence, and it is accurate. And the record of it is written in fossils, which I find more moving than any of the numbers. Some corals lay down a fine growth band each day and a coarser pattern each year, and if you count the fine bands between the coarse ones, you are counting the days in a year at the time the animal was alive. Do that with Devonian corals, roughly 400 million years old, and you get somewhere near 400 days rather than 365. The year has not changed length, the day has. These animals were not recording anything, they were simply growing, and they preserved the rotation rate of the planet, in stone, for 400 million years, until somebody thought to count. The same complication ruins the naive backward extrapolation, and it is worth doing the arithmetic just to see it fail. 3.8 centimeters per year, run backwards, puts the moon at the Earth's surface only about 1,500 million years ago, which is flatly wrong, because we have rocks older than that with tidal patterns preserved in them. The rate has not been constant, because tidal friction depends enormously on the shape and depth of the oceans, and the continents have been moving the whole time. There is even evidence from sedimentary rhythms and banded iron formations that for something like 1,000 million years, in the middle of Earth's history, the day was held near 19 hours. The solar atmospheric tide and the lunar ocean tide nearly cancelling one another, locking the planet's rotation into a resonance until the balance eventually broke. On short timescales, the day wobbles too. Large earthquakes redistribute mass and change it by microseconds. The Tohoku earthquake in 2011 is estimated to have shortened the day by around 1.8 microseconds. There is a free oscillation of the rotation axis called the Chandler wobble, with a period of about 433 days, discovered in 1891, whose energy source is still not fully settled, and the whole reason leap seconds exist is this mismatch between the atomic second, which is fixed, and the Earth's rotation, which is not. But the direction of travel is not in doubt. The moon is leaving, the day is lengthening, and there is an end state, which we can see, because another pair of worlds has already reached it. Pluto and Charon are tidally locked to each other, both of them, mutually. Charon shows the same face to Pluto, and Pluto shows the same face to Charon, permanently. Their day, their month, and their orbital period are all the same number, about 6.4 Earth days. There is nothing left to trade. The transaction has completed, the ledger is closed, and neither body can give the other anything more. That is where the Earth and Moon are headed, though the Sun will have destroyed both long before they arrive. So this is what you are inside tonight. A slow settlement between two bodies, 400,000 kilometers apart, in which your planet is handing over its rotation at a rate of a few centimeters of lunar distance per year, and there is nothing anyone can do about it, and nothing anyone should want to do about it. 86,164 seconds. It was a slightly smaller number when the pyramids were built. It will be a slightly larger one tomorrow. Nothing is turning it, and something is very slowly stopping it. Part 9. The one thing you cannot hide. Here is a question that sounds simple and has never been properly answered. Galileo pointed out, 400 years ago, that if you are below decks on a smoothly sailing ship with the windows shut, there is no experiment you can perform to determine whether the ship is moving. Drop a ball and it falls straight down. Pour water and it pours normally. Watch flies circle a lamp and they circle exactly as they would in a harbour. Uniform motion is undetectable from inside. There is no such thing as being at rest in any absolute sense. There is only being at rest relative to something else. This is the foundation of relativity, and it is one of the most thoroughly confirmed principles in physics. Now put a windowless room on a turntable. Everything changes. You can feel it immediately. Objects drift toward the walls. A pendulum will not hang straight. Water in a bowl climbs the sides and dips in the middle. A gyroscope in the corner slowly reorients. And from those observations, using only equipment inside the sealed room, you can calculate exactly how fast you are rotating and about which axis, and without ever looking outside. You cannot tell how fast you are moving. You can always tell how fast you are turning. Isaac Newton saw this and understood it was profound. In the Principia, in 1687, he made the point with a bucket. Hang a bucket of water from a twisted rope and let it go. At first, the bucket turns and the water does not, and the surface stays flat. Then friction gradually brings the water up to speed, and as it begins to rotate with the bucket, its surface becomes concave, climbing the sides. Now grab the bucket and stop it. For a moment, the water keeps turning, and the surface stays curved, even though the water is now rotating rapidly relative to its container. So the curvature of the surface has nothing to do with motion relative to the bucket. It tracks something else, some absolute rotation, relative to nothing in particular. Newton pushed it further with a second thought experiment that is even more uncomfortable. Imagine two globes connected by a cord, alone in an otherwise completely empty universe. Nothing else exists. No stars, no other matter, no reference points of any kind. Now suppose the pair is rotating about their common center. There is tension in the cord. You could measure it. You could calculate the rate of rotation from it. Rotating relative to what? There is nothing else in that universe to rotate relative to, and yet the cord is taut. Newton's conclusion was that space itself is absolute, a real, existing background that rotation is measured against, even when it is empty. It was a conclusion he was not comfortable with, and could not avoid. Léon Foucault turned the argument into a public demonstration in 1851. He suspended a pendulum 67 meters long from the dome of the Panthéon in Paris, with a heavy brass-covered bob and a pin on the bottom that traced a line in sand. He set it swinging and let people watch. A pendulum's swing plane, left alone, does not turn. Nothing is pushing it sideways, and yet as the hours passed, the line in the sand crept steadily around, degree by degree, and by the end of the day it had rotated visibly. The pendulum was not moving. The building was turning underneath it, and everyone in Paris could come and look. For a great many people, that was the first direct evidence they had ever seen that the earth rotates, which did not require trusting an astronomer about the sky. It was there, in a church, drawing a line in sand. I want to stop on the strangeness here, because it deserves a moment. You can be carried across the universe at any speed whatsoever, and never know it. You are being carried right now. 5 nested motions, hundreds of kilometers per second, and not one of them detectable by any sensation available to you, or by any experiment you could run in a sealed room. Speed is not a fact about you. It is a fact about you and something else, together. But rotation is a fact about you alone. Turn by 1 degree, and physics knows. There is no way to hide it, no reference frame in which it goes away, no perspective from which you are not rotating. It is written into your circumstances in a way that velocity never is, and there is no agreed explanation for why. Ernst Mach thought Newton's answer was cheating. In 1883, in his History of Mechanics, he pointed out that Newton's empty universe thought experiment is not an experiment at all, because you cannot do it and never will. In the real world, the water in the bucket is not rotating relative to nothing. It is rotating relative to the distant stars. Mach's suggestion, and it was a suggestion rather than a theory, was that the fixed stars, the total distribution of matter in the universe, are somehow responsible for defining what counts as not rotating. He observed dryly that Newton's bucket is only a few inches thick, and that nobody knows what would happen if the walls of the vessel were, in his phrase, several leagues thick and correspondingly massive. Einstein found this compelling. He gave the idea its name, Mach's principle, in 1918, and hoped that general relativity would turn out to embody it fully. It does not. It embodies it partially, in ways that are genuinely surprising, and refuses it in others. That is the honest state of the question, and it has been the honest state of the question for 100 years. Here is the part general relativity does deliver, and it is remarkable. A rotating mass drags the geometry of space-time around with it. Not the matter nearby, the geometry itself. Space in the vicinity of a spinning body is slowly wound around, and anything sitting in that space is carried along whether it wants to be or not. The effect is called frame dragging, and it means that Mach was at least partly right. The local definition of not rotating really is influenced by the matter around you. Measuring it took 47 years, 2,000 people, and one of the most demanding experiments ever flown. Gravity Probe B launched in April 2004. It carried 4 gyroscopes made of fused quartz, spheres so close to perfect that if one were scaled up to the size of the Earth, its tallest mountain would be a couple of meters high, among the most spherical objects human beings have ever manufactured. They were cooled with superfluid helium, coated in superconducting niobium, spun up, and their orientations tracked by magnetometers sensitive enough to detect the field of a single electron's worth of circulating current. The satellite pointed at a guide star and simply waited, while the Earth's mass and the Earth's rotation slowly turned the gyroscopes. The final results, published by Francis Everett and his collaborators in Physical Review Letters in May of 2011, gave a geodetic drift, the effect of the Earth's mass-curving spacetime, of minus 6,601.8 milliarcseconds per year, against a predicted 6,606.1, and a frame-dragging drift, the effect of the Earth's rotation, of minus 37.2 milliarcseconds per year, against a predicted 39.2. Understand how small 37 milliarcseconds per year is. A milliarcsecond is a thousandth of a second of arc, and a second of arc is a 3,600th of a degree. 37 of them is roughly the angle subtended by a human hair seen from half a kilometer away. That is the total effect of the entire rotating Earth on the orientation of a gyroscope in orbit above it, accumulated over a full year. That measurement has since been backed up from a completely different direction. The Lagios and Lares satellites are passive metal spheres covered in reflectors, and by tracking the slow twisting of their orbital planes with lasers, the same frame-dragging effect has been confirmed to within a few percent using no delicate instrumentation at all. So this is where 3 centuries of argument leaves us. Rotation is real, in a way that motion is not. A sealed room can measure its own spin. Newton said, "This proves space is absolute." Mach said the distant stars are somehow doing it. Einstein hoped to prove Mach right, and produced a theory that says the nearby matter does partly define what not rotating means, while leaving the deeper question open. Nobody has closed it. And notice what all of this means for the thread we have been following. A quantity you cannot hide is a quantity that cannot quietly disappear. There is no frame you can slip into where your rotation stops being counted. No perspective from which the books do not have to balance. The absoluteness of rotation and the exactness of the ledger are not 2 facts. They are the same fact, seen from 2 sides. Which raises the obvious next question. If rotation cannot be destroyed, and it gets amplified every time something collapses, then what stops it? What happens when a thing spins as fast as it is physically allowed to spin? Part 10. What breaks first? Every other quantity in physics that grows without limit eventually runs into something that stops it. So what stops rotation? The answer is not friction, because there is none. It is not exhaustion, because nothing is being spent. There is no natural process anywhere in the universe that gradually wears rotation down the way air resistance wears down a spinning top. What actually happens is far less comfortable. Rotation increases until something structural fails. Start with the neutron star, because it is the case where the failure is most obvious. Spin any object fast enough, and the material at its equator needs an ever larger inward force to keep it on a circular path. At some rate, the available force runs out. For a star, that force is its own gravity, and the equator simply leaves. The object sheds mass, or comes apart entirely. This is the breakup limit, and for a neutron star, depending on which model of ultra-dense matter you believe, it sits somewhere in the region of 1,500 rotations per second. The fastest neutron star anyone has ever found turns 716 times per second. That is less than half the limit. And this is a real problem, because our surveys are sensitive enough to detect faster ones, and we have been looking for decades, and they are not there. Something is capping neutron star rotation well below the point at which matter tears. The favoured explanation is one of the more unsettling results in astrophysics, and it involves the only counterparty left. A rapidly rotating fluid star can develop a particular pattern of oscillation, a wave in the star's fluid interior, driven by rotation itself, in the same family as the great planetary waves that shape weather on Earth. In a neutron star spinning fast enough, these waves become unstable. They grow, and because the star is enormously dense and the pattern is not symmetric, the growing wave radiates gravitational waves, ripples in space-time itself, which carry angular momentum away. Read that again, because it is the whole point of this part. The star cannot destroy its rotation. Nothing can. So when it is spinning too fast to be stable, it does the only thing available. It hands the angular momentum to space-time, and space-time carries it off at the speed of light, never to return. The discovery paper for the 716 Hz pulsar says exactly this. The authors note that finding a star spinning that fast puts real constraints on those models, because if the instability set in as early as some versions predict, this object should not exist. The ceiling is real, and where exactly it sits is still being worked out. There is a related lesson in how those fast pulsars got fast in the first place, and it is the ledger again, running in reverse. Millisecond pulsars are not young, they are old, cold neutron stars that were spinning slowly and have been spun back up by stealing material from a companion star. Matter spirals in through a disk, and when it lands on the neutron star's surface, it delivers not just its mass, but its angular momentum. Feed a slow pulsar for 100 million years, and you get a fast one. The rotation was not manufactured. It was taken from the orbital motion of a companion that is slowly being eaten. And where rotation does decline, you can usually find the invoice. The Crab pulsar turns about 30 times a second, and is measurably slowing. Its period lengthens by a few tens of nanoseconds per day, which sounds like nothing until you work out what that represents in energy. The rotational energy the Crab is shedding is almost exactly the energy required to light up the entire nebula around it, a cloud several light years across that has been glowing since the star exploded nearly 1,000 years ago. The nebula is not powered by the explosion. The explosion finished long ago. It is powered by the corpse slowing down. Somebody looking at that cloud through a telescope is watching angular momentum being converted, in real time, into visible light. Now the other kind of limit, and this one is geometric rather than material. Black holes rotate, and there is a maximum. It is not a maximum imposed by the strength of any substance, because a black hole has no substance to break. It is imposed by the geometry of space-time itself. Roy Kerr found the exact description of a rotating black hole in 1963, published in Physical Review Letters, 47 years after Karl Schwarzschild had solved the non-rotating case, and widely regarded as one of the hardest calculations in the history of the subject. In Kerr's solution, the spin is expressed as a number between 0 and 1. And 1 is the wall. Push a black hole past that value, and the event horizon disappears, leaving the singularity exposed to the outside universe, an outcome most physicists believe nature forbids, though nobody has proved it does. Real black holes get close. The one in the system, GRS 1915 plus 105, has been measured above 0.98 by studying the temperature of its accretion disk, and the black hole in Cygnus X1 has been reported at a similar value, though it is worth saying that independent analyses of the same object have come out considerably lower, and the disagreement is about how to model the disk rather than about the physics. Somewhere between 98% and the absolute geometric limit is where these objects sit. And because essentially every black hole forms from rotating material and grows by eating more rotating material, the non-rotating solution, the neat, simple, spherical one in every textbook, is almost certainly a description of nothing that has ever existed. Come close to one of these, and the strangeness becomes physical. Outside the event horizon of a rotating black hole, there is a region called the ergosphere, and inside it, something happens that has no equivalent anywhere else. Space-time is being dragged around so forcefully that standing still becomes impossible. Not difficult, impossible. There is no amount of thrust, no engine of any conceivable power that could hold you stationary relative to the distant stars. You are inside a region where the geometry itself is turning, and everything in it must turn with it. You can still escape. The horizon is further in, but you cannot be still. The frame dragging that took Gravity Probe B a decade and 4 almost perfect quartz spheres to detect at a level of 37 milliarc seconds per year is, out here, absolute and inescapable. That rotation is also extractable. Roger Penrose showed that if you drop an object into the ergosphere and split it in two, sending one piece further in and letting the other escape, the escaping fragment can carry away more energy than the whole object brought in. The extra energy comes from the black hole's rotation, which is correspondingly reduced. It is a way of mining a black hole, and the mining is limited by exactly the quantity we have been tracking all night. The same story plays out at the small end, where the objects are rubble rather than neutrons. Sunlight falling on an irregularly shaped asteroid is absorbed on one side and re-radiated as heat, and because the shape is uneven, the re-radiation produces a very slight net torque. Over millions of years, that torque spins the asteroid up. Many small asteroids are not solid rock, but loose piles of gravel held together by their own feeble gravity, and when the spin-up reaches the point where that gravity can no longer hold the equator on, they come apart, sometimes shedding material into a small moon, sometimes splitting into a pair. It is the breakup limit again, at a scale of kilometers instead of stellar masses, driven by nothing more dramatic than sunlight. So there is the pattern, and it holds at every scale. Rotation is never worn away, it is never spent. It accumulates, and it is amplified by every collapse, and it stops only when the thing carrying it fails, when matter tears, when geometry runs out of room, when a pile of gravel flies apart. And even at that final wall, nothing is destroyed. The neutron star at its limit does not lose its rotation. It exports it into the fabric of space-time as waves that will travel outward forever. Space-time turns out to be the last available counterparty, and even it will take a deposit. The books balance at the wall too. They always have. Which leaves one question standing, the one we have been putting off since the halfway mark. If nothing anywhere can ever destroy a single unit of this stuff, what is the total? We are almost ready. There is one last thing to see first, and it is the biggest thing in the video. Part 11. The pattern goes all the way up. If rotation were an accident of local circumstance, a bit of gas that happened to swirl this way rather than that, then spin axes across the universe should point in random directions. Every galaxy would be tipped whichever way its own history tipped it, with no relationship to anything else. The sky would be a scatter of unrelated orientations. It is not, quite. In 2013, Elmo Temple and his collaborators published an analysis in the monthly notices of the Royal Astronomical Society, examining how the spin axes of galaxies relate to the filaments of the cosmic web they sit inside. The cosmic web is the largest scale structure we know of. Galaxies are not scattered evenly through space, but strung along threads, gathered at the intersections of those threads, and almost entirely absent from the enormous voids between them. It looks, in the survey maps, like a network of fibers surrounding empty rooms. What Temple and his colleagues found is that spiral galaxies show a statistical tendency to have their rotation axes aligned along the filament they inhabit. Elliptical galaxies show the opposite tendency. Their axes prefer to lie perpendicular to it. The correlations are not overwhelming. Individual galaxies are all over the place. But across large samples, the preference is real, and it is measurable. That difference between spirals and ellipticals is itself informative, and it is worth a moment. A spiral galaxy is a rotating disk. Its stars move in an organized way around a common axis, which is why the shape exists at all. An elliptical is not. Its stars move on randomly oriented orbits, and it has comparatively little net rotation. The reason is that ellipticals are built by mergers, and mergers are where the ledger does its cruelest arithmetic. Combine two galaxies whose rotations point in different directions, and the resulting object holds the sum, which, when the contributions oppose each other, can be very much less than either one started with. Nothing was destroyed there either. The opposed contributions simply cancelled in the total, and the energy that used to be organized rotation is now disorganized motion in 1,000 million different directions. There is a further wrinkle in the alignment data that makes it more convincing rather than less, because it was predicted before it was found. The preferred orientation of a galaxy's spin axis appears to depend on its mass. Below a certain threshold, spin axes tend to lie along the filament. Above it, they tend to lie across it. Somewhere in between, there is a transition, a mass at which the preference flips over. Simulations of structure formation produce exactly this behavior, and the reason is that low-mass objects mostly acquire their rotation from material flowing to them along the filament, while high-mass objects have grown by swallowing other objects arriving from directions the filament does not favor. Two different histories, two different orientations, one crossover point between them. That a prediction this specific came out of the models before the surveys were good enough to check it is a large part of why the picture is trusted. But the alignment of the spirals is the point here, and the reason it matters is that it is precisely what tidal torque theory predicts. Go back to the beginning of the video, to the lumpy patch being twisted by its lumpy neighbours. The gravitational field doing that twisting was not a local accident. It was the large-scale distribution of matter in that region, and that same distribution is what subsequently collapsed into the filament the galaxy now lives in. The field that spun the galaxy up and the structure that surrounds it today are the same thing at two different stages of its life. So the galaxy's spin axis carries a memory of the shape of the matter around it 10,000 million years ago, and the filament is what that matter became. The alignment is a fingerprint. It is the twist from the beginning of this story, still legible. And then, in 2021, the pattern went one rung higher than anyone expected. A team led by Peng Wang published a paper in Nature Astronomy examining whether the filaments themselves are rotating, not the galaxies in them, the whole structure, turning about its own long axis. The method is worth describing because it is clever and because it explains the limits of the claim. You cannot watch a filament turn. The timescales are absurd. What you can do is look at the galaxies within it and measure their velocities along your line of sight, using redshift. If a cylinder is rotating about its long axis, then galaxies on one side of the spine are moving toward you, and galaxies on the other side are moving away, systematically. That difference is small and buried in noise for any single filament. So they identified thousands of filaments in the Sloan Digital Sky Survey, oriented them all the same way, and stacked them, letting the random motions average out and any common signal accumulate. The signal was there. Galaxies on one side of the spine systematically redshifted, on the other systematically blue-shifted, consistent with rotation. These filaments are hundreds of millions of light-years long and only a few million light-years across, threads whose length is measured in a substantial fraction of the observable universe. If the result holds, they are the largest objects known to carry any angular momentum at all. Try to hold the size of that for a moment, slowly, because the numbers stop meaning anything if you take them at speed. Light takes 8 minutes to reach here from the sun. It takes 4 years to reach the nearest other star. It takes 100,000 years to cross this galaxy. And a filament is a structure that light would need hundreds of millions of years to travel the length of, containing thousands of galaxies strung along it like water on a thread, each of those galaxies holding 100,000 million stars. That is the object we are now discussing. And the claim is that it is turning, not that the galaxies inside it are orbiting a center, which they are not, but that the entire thread has a slow, coherent twist to it, one side coming toward us and the other going away. I want to be careful with the word if, because the paper itself is. It is titled with the word possible, and that is not modesty, it is accuracy. This is a stacked statistical signal, not a picture of something turning, and stacking analyses are exactly the kind of thing that can go wrong in subtle ways. It is a frontier result. It is being tested. The testing has already produced something. In 2025, a single filament, roughly 15 megaparsecs long, about 50 million light-years, was characterized individually, on its own, without stacking, at a distance corresponding to a redshift of about 0.032, and it too showed rotation. One object, rather than a statistical average. That strengthens the case considerably, without closing it. So here is where the census we started an hour ago now ends. Atoms turn, planets turn, stars turn. The corpses of stars turn, some of them hundreds of times a second. Black holes turn, right up against the geometric limit. Galaxies turn, and the threads that galaxies are strung along, the largest coherent structures that exist, appear to turn as well. At every scale that has been examined, from the subatomic to structures spanning a measurable fraction of everything we can see, the answer has been the same. There is no level at which the turning stops. There is no size at which objects settle down and hold still. Which makes the next thing the strangest fact in this entire subject. Because there is exactly one scale left, and at that scale, the answer changes. Part 12. The one thing that does not turn. We have been climbing for a long time. Let us go all the way to the top. Pull back from the Earth until the solar system is a point. Pull back until the galaxy is a smudge. Pull back until galaxies are individual specks, and the specks resolve into threads, and the threads into a network of filaments wrapped around enormous empty rooms, and then keep going until the entire observable universe is in front of you. Everything there is that anyone can ever see, all 93,000 million light-years of it, held in a single frame. And now notice what is missing from the picture. At this scale, nothing is turning at all. That is not a limitation of the view. It is a measurement, and it is one of the tightest measurements in cosmology. The question is not a new one, and it is not a silly one, because general relativity permits a rotating universe. Kurt Gödel proved that in 1949, in the Reviews of Modern Physics, and he did it as a birthday present for Einstein. The two of them were colleagues at Princeton by then, walking home together most afternoons. Gödel constructed an exact solution to Einstein's equations, describing a universe filled with rotating dust, and it is a genuinely valid solution. It also has a property that troubled Einstein considerably. In Gödel's universe, there are closed time-like curves running through every single event, which means that from any point, a sufficiently determined traveler could follow a path that returned them to their own past. Gödel's universe does not expand, which rules it out as a description of ours on other grounds entirely. But its existence settled one thing permanently. A rotating universe is not forbidden by the mathematics. Whether ours rotates is a question you have to go outside and check. Einstein's published response to the gift was polite and visibly uneasy. He wrote that solutions of this kind were an important contribution, and that the problem of whether they could be excluded on physical grounds would need further examination. He had spent decades building a theory of space and time, and a colleague had just handed him a mathematically impeccable version of it, in which the past is a place you can visit. He did not have a good answer, and he said so in as few words as he could manage. So how would you check? A rotating universe is not something you can step outside of and observe from a distance. There is no outside. And I should head off a confusion here, because there is a well-known measurement that sounds like it contradicts everything I am about to say. We are not at rest with respect to the microwave background. Our galaxy, and the whole group of galaxies it belongs to, is moving through that light at something over 600 kilometers per second, and the effect is plainly visible. One side of the sky is slightly hotter than the other, which is simply the Doppler shift of our own motion. So there is a sense in which we can measure our absolute velocity after all, but only relative to the radiation, which is a thing, not a background frame of the universe. And crucially, that is a translation. We are moving in a straight line through the oldest light in existence. That is a completely different quantity from rotation, and it says nothing at all about whether the universe turns. But it would leave a mark. If the whole universe had a net rotation, it would have a preferred axis, and expansion would proceed differently along that axis than across it. That distortion would be imprinted in the oldest light there is, the microwave background, released when the universe was around 400,000 years old and cool enough to become transparent, and now spread across the entire sky in every direction. A rotating universe twists the pattern of hot and cold spots in that light into a characteristic spiral form. Nothing local can produce that pattern. Nothing in a galaxy, nothing in a cluster, nothing in the foreground. It is a signature of the universe as a whole, and it is either there or it is not. The catalogue of possible shapes for such a universe was worked out long before there was any cosmology to apply it to. Luigi Bianchi classified the possibilities in 1898 purely as an exercise in geometry, sorting the ways a homogeneous but not isotropic space can be built. Those classes sat unused for decades until the universe turned out to need them. In 2016, Daniela Sade, Stephen Feeney, Andrew Ponson, Hiranya Paris, and Jason McEwen published the definitive test in Physical Review Letters. Previous analyses had checked one form of anisotropy at a time, using the temperature of the microwave background alone. This one used the temperature and the polarization together, and it allowed every degree of freedom in the possible geometries to vary at once, so that no combination could hide. The result, for the mode that corresponds to overall rotation, was a limit on the vorticity of the universe of less than 4.7 times 10 to the minus 11 relative to the rate at which the universe is expanding, an order of magnitude tighter than anything previously achieved. And considering all the ways the universe could be lopsided together, the analysis disfavored any anisotropic expansion at odds of about 121,000 to 1. Put in plainer terms, over the entire history of the universe, the total amount by which it has turned is consistent with zero, and if it is not exactly zero, it is smaller than roughly 1/10,000 millionth of a rotation. The universe is not spinning. Everything inside it is. Every planet, every star, every stellar corpse, every black hole, every galaxy, every filament, without a single exception, anywhere at any scale. And the thing they are all inside is perfectly still. Now, I said earlier that I would tell you when something was contested, so here is the one live challenge to that picture, and it deserves an honest hearing. Lior Shamir has argued across a series of papers that spiral galaxies do not divide evenly between those that appear to rotate clockwise from our vantage point and those that appear to rotate counterclockwise. In February of 2025, he published an analysis in the monthly notices of the Royal Astronomical Society of the deep field imaged by the James Webb Space Telescope for the Advanced Deep Extragalactic Survey. Of 263 galaxies in that field, with a rotation direction he could identify, roughly 2/3 appeared to turn one way and 1/3 the other. In a much larger sample drawn from other surveys, the numbers were 38,718 against 37,917, a small excess, but with a statistical significance of around 1 in 500. The headlines that followed suggested that the universe was born rotating, or that we are living inside a black hole. Here is the more likely explanation, and it is not mine. Shamir himself offers it as one of two possibilities in the paper. Our own galaxy is rotating. We are inside it, moving with it. Galaxies whose rotation runs counter to ours are, because of the Doppler effect, very slightly brightened relative to those rotating with us. And in any survey that has a brightness limit, which is every survey, being very slightly brighter means being slightly more likely to make it into the catalogue at all. A selection effect of that kind would produce exactly this asymmetry from a universe in which the true distribution is perfectly even. There are other candidate explanations too, none of them cosmological. Automated classification algorithms can carry a handedness bias in how they process an image. Human annotators demonstrably do. And a deep field is a very small patch of sky, which makes it vulnerable to whatever happens to be in it. None of this makes the observation uninteresting. It makes the interpretation unestablished, which is a different thing, and it is worth sitting with the possibility that the most provocative claim about cosmic rotation in the last 5 years may turn out to be a measurement of our own galaxy's spin leaking into the brightness of the galaxies we are counting, which is its own kind of vertigo. The measurement from the microwave background stands, and it is telling us something that I think is genuinely difficult to sit with. If the total is 0, and every object in the universe is turning, then every rotation is being cancelled by another rotation somewhere else. The Earth's spin is not something the Earth has. It is one half of a pair. Somewhere out there, and not somewhere identifiable, not somewhere you could point to, because the cancellation happened at scales and epochs that no longer have addresses. There is an equal and opposite contribution that balances it exactly. The patch that twisted our patch was twisted back. That material has long since been rearranged into other galaxies and other stars, and whatever is holding the other half of our rotation today, we will never see it and never know what it is. Every spinning thing in the universe is one entry in a double-entry ledger whose bottom line is nothing. That is the fact. We have one part left, and in it I am going to tell you why. Because the reason is not that the universe happened to come out balanced. The reason is stranger than that, and it is the reason the title promised. Part 13. The Strange Reason. So here it is, plainly, the thing the whole video has been walking toward. Everything in the universe spins because the universe does not. I want to take that apart slowly, because it is not a paradox, and it is not a piece of wordplay. It is a chain of 3 statements, each of which we have already established, and the chain has a conclusion most people find genuinely difficult the first time they meet it. The first statement is that angular momentum is conserved because space has no preferred direction. Noether, 1918. Not because of a force, not because of a property of matter, because of a symmetry, the fact that you can point an experiment any way you like, and physics behaves identically. That symmetry, and nothing else, is what makes rotation permanent. The second statement is the one that gets skipped, and it is where the strangeness enters. Noether's theorem is bookkeeping. It tells you which quantity is conserved. It says absolutely nothing about how much of that quantity there is. A universe with perfect rotational symmetry and 0 rotation everywhere in it is exactly as mathematically consistent as ours. The theorem does not require that anything turn. It requires only that whatever turning exists is never created and never destroyed. So the symmetry explains the persistence. It does not explain the amount. And the third statement is the measurement. The amount, summed over everything, is 0. Now put the 3 together. The total is fixed, and the total is nothing. But a total of nothing does not mean nothing is happening. 0 is a sum, and a sum can be built out of enormous opposing parts. Take a quantity whose total is 0 and divide it among 100,000 million galaxies, and every one of those galaxies gets a share that is not 0. It only has to be cancelled by an equal and opposite share held somewhere else. That is the answer. Rotation is not something an object has. It is one half of a pair. Every spinning thing in the universe is one entry in a double-entry ledger, and its counterpart is real, and out there, and permanently beyond reach, because the cancellation was arranged at scales and epochs that no longer have addresses. The Earth is not spinning because something spun it. The Earth is spinning because a lumpy patch of gas pulled unevenly on another lumpy patch of gas 13,000 million years ago, and the two of them acquired opposite twists, and one of those twists came down through a collapsing cloud and a young star and a ring of debris and arrived here, and the other one went somewhere we cannot follow. Everything spins because nothing does. That is the strange reason everything in the universe spins. And there is a symmetry to the answer that I find quietly satisfying once you notice it. Consider what a genuinely rotating universe would mean. It would have an axis. There would be a direction that was different from the other directions. A cosmic orientation, built into everything, unavoidable. And the moment that is true, the symmetry that Noether's theorem depends upon is broken at the largest scale, which means the very law that makes rotation permanent would lose its footing precisely where the rotation was largest. A universe with a net spin would be a universe in which spin was not properly conserved. The conservation law and the zero total are not two separate findings that happen to sit next to each other. They are the same fact, approached from opposite ends. Rotation persists because space has no preferred direction. Space has no preferred direction because the total rotation is 0. Each one is why the other is true. And I promised honesty about the gaps, so here are the two that remain, because they are not small. The first is that nobody can derive the amount. The symmetry explains why rotation is conserved. It does not explain why there is any to conserve, why the distribution was not simply flat, every patch perfectly still, a universe with rotational symmetry, and no rotation in it anywhere. The standard account traces it back to the density fluctuations in the early universe, and traces those back, in turn, to quantum fluctuations stretched to cosmological scale during inflation. Which means that on the best account anyone has, the rotation of the Earth beneath you tonight is the amplified residue of quantum noise in an almost empty universe. Noise magnified first by inflation, then twisted into a torque by uneven gravity, then multiplied by geometry through 13,000 million years of collapse. That is either a complete explanation or no explanation at all, depending on how you feel about a chain that ends in noise. It is worth being clear that physics does not consider this an embarrassment. Tracing a structure back to a random fluctuation is a legitimate and often correct thing to do. The distribution of stars in the sky has the same kind of answer. But there is a difference between explaining a pattern and explaining a quantity, and what remains unexplained here is not the pattern, it is the number. And the second gap is the one from the middle of the video, which never closed. Rotation is absolute in a way that motion is not. You can be carried anywhere, at any speed, and never know. You cannot be turned by a single degree without physics knowing. Newton said, "This proves space is a real thing." Mach said the distant stars are somehow responsible. Einstein hoped to settle it and produced a theory that gives half an answer. 339 years after the bucket, that question is still open, and every rotating object in the universe is sitting inside it. So let me leave you where we started. You are lying still. Nothing is pressing on you. Nothing is moving that you can feel. And beneath you, the planet is turning, once every 86,164 seconds, as it has for 4,500 million years. Nothing is turning it. Nothing ever did. It was handed this rotation by material that no longer exists, in an arrangement that no longer exists, and it will hand a little of it to the moon tonight, a few centimeters worth, as it has every night of your life, and every night before there was anyone here to have a life. The day is a fraction longer than it was when you were born. The moon is a little further away. Somewhere out there, in a direction nobody can point to, the other half of this planet's rotation is being carried by something we will never identify. And the sum of all of it, every planet, every star, every pulsar, every black hole, every galaxy, every filament, every turning thing there has ever been, comes to nothing at all. Sleep well.